Now let's see a question on this multiplication theorem. Let us assume that there is a lock, okay, and then there is a bunch of keys. So 1 2 3 4 5 6 7 8. Let us say there are eight keys like this. There is one lock and 8 keys, and only one of them is going to be the correct fit. Now we'll conduct an experiment in which each time we'll pick up a key and we try to open the lock, and in case if you open it, we'll be happy. Otherwise we'll throw away that key and pick up the next one from the bunch, which means it is similar to the question where we are going to pick up the balls from a box and we are not going to replace the ball before picking up the next one. Got it? So it is actually a question which is similar to without replacement, right? So now whenever we are talking about the cases where we are not going to replace and we are going to conduct the experiment, then we have to get into picture the conditional probability, because the probability is going to change, right? So now the question is, what is the probability that we will be able to open the lock in the 7th try? Okay, so now we have 8 keys. What will be the probability that we will be able to open the lock in the 7th try? Let us say Li is the event in which the lock gets opened in the 8th try. If Li is the event in which lock gets opened in 8th try, then how can you write this question? So you can write this like this: probability of L1 bar, which means lock should not open in the first try, intersection L2 bar, which means L2 complement, which means lock should not open in the second try, so on, right? So lock should not open in the third try, lock should not open in the fourth try, lock should not open in the fifth try, lock should not open in the sixth try, but lock should get opened in the 7th try, isn't it? Now you can open it and you can write it in the chain form in like conditional probability, right? So how can you write it? It is P of L1 complement multiplied with P of L2 complement given L1 complement multiplied with P of L3 complement given L1 complement and L2 complement, so on, right? So what will be the last term? P of L7, which means 7th try should succeed, given that first try didn't succeed, second try didn't succeed, so on, 6th try didn't succeed. That is how you should expand it. Now what is the probability that the first try will fail? So out of these 8 keys, 7 keys are going to be wrong keys. So in the first try you are going to choose any one of these 7 keys out of the 8 keys, right? And then once you try it, once you fail, then we definitely know that that key which you have chosen in the first try is wrong and we are going to throw it away. Then there will be 7 keys remaining. Let's say you have picked it up, you have thrown it out, then we have 7 keys remaining, out of which 6 are wrong keys. Now in the second try, if it has to fail, you should pick one of the 6 wrong keys, total out of 7 keys, right? Similarly, for the third try to fail, we have to pick one of the 5 wrong keys out of 6 keys, and for the next try we have to pick one of the 4 wrong keys out of 5 keys, right? So this is the first try, second try, third try, fourth try, and next we have to find out the 5th try. For the 5th try we have 3 wrong keys out of 4 right keys, right? And then for the 6th try we have 2 wrong keys out of 3 total keys, and for the 7th try we have actually 2 keys remaining, out of which one is the right key and the other is the wrong key. So this is the answer, right? So again, this is also a kind of application of multiplication theorem. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs universities better than IITs. They have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.